Welcome back to the classroom. My name is Mr. Wong. Again, today we're going to be explaining another exam style question. This time on this particular scenario, as you see for projectile motion, this is on the ATAR notes, question 6. So let's begin with projectile motion.
So, in order to start our question, we are looking at question A here. So question A says, outline the axes below, or on the one of the axes below, draw a graph for the acceleration of the ball over time while it is in flight. Okay, one of the misconceptions people often think is that the acceleration is going down like that. Okay, that's usually the first interpretation. But what you don't actually know is that's actually more for question B, which we'll talk about in terms of the speed or the velocity of the ball over time. Now, if I'm talking about the acceleration, we need to do two components. We need to consider two components. We're looking at the y component, and we're also looking at the x component. So we're trying to look at if there's any acceleration going on there. We know that in high school physics, we always say that there is no air resistance. So if there's no air resistance, effectively my acceleration is 0, okay? The x component. So I know for sure the x component is 0. The next thing I know is the only acceleration that's affecting the y component is the acceleration due to gravity. Okay, that's the only acceleration. And so AY has a value of negative 9.8 meters per second squared. So what I would draw here is minus 9.8 meters per second, and it would just be a straight flat line. And that would be how you would draw question A out. Question B, it says draw a graph of the speed of the ball over time. So you can do it, two ways. You can, this one is technically asking about speed, and I'll also do one for velocity. Okay, so let me just draw one for speed over here first. So if it's speed over time, we can see that as the ball gets further up, or as it goes up, it reaches a peak height. Now at peak height, effectively, it has a 0 vertical velocity there, that point there. But the velocity at that point for the horizontal component is still the same as what you had initially. So that value is not going to change. So if I was to try and draw that out, okay, it will look something like this. It will start slowing down and it will get to peak height. That's where it stops. As the ball is now speeding up downwards, that speed would also gain traction and go here where it's leveled down, and then as it passes the original launch point, it will go above, like so. If you were trying to draw out the velocity, then it'll look something like this. So we come down here, and I'm just assuming some arbitrary point. Let's just say this is like peak height point, okay? And then that velocity is decreasing. Now you can see that this velocity again is going down and down and down. So it's increasing further in the negative direction. So the velocity will keep going down like that for whatever time you would like until we actually get rid of this, until this point here. That's the point where it lands. Okay. Further down. Okay. Question C, it says sketch and label the changes of kinetic energy for the projectile shown. So let's just draw out our graph, sketch it out. Okay, kinetic energy as the y-axis, t for time. Okay, same idea. It will be very similar to what we drew the speed diagram. It's going to decrease and it's going to reach a plateau point. That plateau point is for the peak height. So this is where peak height is. Okay, and then as it begins to speed back up, it's going to increase again in its overall kinetic energy. So it's going to drive up and go further than original because you are falling that extra 1.2 meters in comparison to its launching point. Okay, the next thing we can look at is the ball here. So the ball takes 3.5 seconds to land on a grass area. How long is the grass area? This one is a very straightforward one. You just use Sx equals to Ux times t. Okay, t I've already got a value for that. That's 3.5 seconds. And all I have to do is work out what Ux is. And that's kind of given to you already. So Ux is equal to 11 times cos 60. Okay, so 11 cos 60 times 3.5 seconds. That would give me an answer of, plug it in my calculator, 19.25 meters.
And that concludes the question. If you found videos explaining exam questions useful, then hit that like button and press subscribe. We'll go through more questions from the HSC physics papers, and so I'll see you next time.